Alright, scholars, so the review bell work, let's go. Without doing any calculations, that means we don't have to find any number. Describe the rate of change for function f on the interval -3 to 0. So that means I'm looking at x -3 to x equal to 0. -3 is right here, x equal to 0 is right here. So we are looking at pretty much a to b. Explain telling if the rate of change is positive or negative. Alright, so rate of change is positive or negative. Let's dissect a little bit. That means the slope is positive or negative. Okay, what does positive slope mean? That means it's increasing. That means negative slope means the function is decreasing. So please know all the synonyms of it, okay? So if I say function is increasing, f is increasing, is same as positive slope. That's also same as positive rate of change. And then all the negatives will be equivalent as well. So what are we doing over here? Is it increasing or decreasing? The function is going down. It's decreasing. So I'm going to say rate of change is negative because the function is, sorry, it's too early, decreasing. Okay? Alright, next. My assumption, it's going to ask about whether rate of change is increasing or decreasing. Is that right? Yes, rate of change is increasing or decreasing. What does that mean, folks? When the rate of change is increasing, that means slope is increasing. That means it is concave up. So increasing, decreasing rate of change has to do with the concave up and concave down. So please look at it. Quick reminder, if it's the part of the U shape that's a concave up, upside down U shape, then it's concave down. So that appears to be part of the smiley face part. So it is concave up, therefore rate of change is increasing because the graph is concave up, -3 to 0. Okay? Alright, use the graph above to find the average rate of change from -3 to 0. You have a similar problem like that on your FRQ, the study guide. Just want to point that out. However, on the FRQ, okay, let me see the graph. Oops. You have the function. So when you want to evaluate the y value, you're going to plug it into the x to find the y value. Or at least for this one, I don't have any function to plug it in, so you're going to just heavily rely on the graph. Does that make sense? So which one is most accurate, graph or function? The equation of the function. How do you find the average rate of change? So remember the formula, f of b minus f of a, b minus a equal to. So we are looking at -3 to 0. So -3 is a, b is 0. Plug it in. F of 0 minus f of -3, 0 minus -3. Be careful with the negatives there. Then my denominator becomes 3. What about my numerator? F of 0, I'm using the graph because that's all I have, appears to be 1. F of -3 appears to be 4. So average rate of change is -1 there. Okay, let's keep going. The selected values are shown below to the left, which of the following pairs about G could be true. So I'm asking about even function. Okay, so the first part is even or odd. The second part is concave or concave down. So I'm doing two different things simultaneously. So let's look at even and odd function first. Even function is, folks, the y-axis symmetry, right? So whatever you have on the right, you better have on the left. That means same y value, opposite x. Odd function, on the other hand, is the origin rotation. So whatever you have on the left, you better have on the right outside corner. So that means x changes sign and y changes sign. So I need you to look at this table. That's useless one. Let's look at these two. Why am I using those two? Because those are the only one that I have opposite x's. Like for example, -7, I don't have 7, so I can't use that. Alright, so I'm looking at the x change of sign, y change of sign. So both x and y change, that means it's an odd function. Does Does it make sense? Because that's odd, both x and y. What about concavity? We have to go back, shift the gear. In order for us to check the concavity, first determine how x is increasing. Is it increasing in equal length interval value? Let's see, plus 2. Yes, it is. Now let's look at how your y output is increasing. So 1, am I doing math right? 4, 5, and 6. So I'm going from plus 1, plus 4, plus 5, plus 6. Is it increasing or decreasing? The rate of change is increasing. So concave up. B. Okay. Alright, next. And behavior. Remember the finger thing, up and down. Even function, same direction. Odd function, opposite direction. Which hand tells me about the sign of the leading coefficient? Your right hand. So first, let's just make sure it's in standard form, which you don't need to do that, but I like it. Okay, in other words, what's the biggest exponent? This one, right? Negative 7x to the 4th power. I don't see any other x to the 4th power, so that's what I'm using. Leading coefficient is negative, so my right hand goes up. Even degree, both are the same direction. So I'm looking at, folks, left hand behavior going down, right hand behavior going down. However, look at your choices. These are the limit statement. The first ones are all x goes to negative infinity, x goes to negative infinity. That's the left hand limit. Where is it going? Down. So it's going to be negative infinity. A or B. The second section is x goes to positive infinity. So I'm looking at the positive x, the right hand behavior. It's going down as well. So, okay. Which of the following is true? All right, you're looking at the two things again. Is the function increasing or decreasing? Second, what is the rate of change? Is the rate of change increasing or decreasing? So let's look at one at a time. All right, look at it. Is the function increasing or decreasing? It is going up, so it is increasing. Now, rate of change is increasing versus decreasing, folks. Rate of change increasing has to do with the concavity. Look at it. Does it look like a happy face or sad face? Sad face. So that is concave down. Concave down. That means rate of change is decreasing. Okay? Alright. This one, I need a calculator, so give me 1 second.